Thus, you must realize.
Max, I'm so proud of you.
And Gabe.
I can't even tell you how proud I am of you. I'm so happy.
It's genuinely a little bit impressive.
You even got your intonation down. I'm so proud of you.
Next time, Max, I can give you more than a week for this one. Next time, I want the intro.
I know, that's what I was worried about. That'd be
But
great.
I want you, no backing track.
Yeah,
you have to do the sounds.
What is it all about? Science.
What has science done for me lately? Yeah. It's just a physics excursion. Okay.
Thus, you must realize that you have no idea before you can know the idea. We scan across all the frequencies if we want to learn anything new. Let us begin.
What has physics done for me lately? Second more, the equation E is equal mc squared. We have now acquired a fateful power to alter and to destroy nature. That's like when you're in physics and you go to Dreamworld saying, this is a physics excursion. Science, what is it all about? The whole of human history all falls in the dust or one stroke of a nail file. You can't really get to grips with evolution unless you realise what an enormous amount of time our own planet is only a tiny part of the vast cosmic tapestry, a starry fabric of worlds yet on top.
Oh, you had that ready.
You are tuned into what can be described as the best radio station on this blue dot we call Earth. It is, of course, 4ZZZ, connecting and amplifying voices of our community, be it on your conventional wireless radio by tuning into the classic frequency of 102.1 FM, digital devices such as DAB or smart speaker, listening via the Community Radio Plus app, or streaming us live from our sensational website at 4ZZZ.org.au. And, of course, you can always listen back to us or any 4ZZZ show, for that matter, using the ingenious on-demand feature also found at that URL. We also now have a weekly podcast of the show for your listening pleasure, curated by Toby, a condensed version of the show without the music, which my mum prefers. So search for our show name, which is, of course, No Idea, spelt with a K, your weekly dose of science. And joining me to delay today.
Delay is the new thing.
Some
Right
gold
now.
standard science. May I please introduce Peta
Hello.
and Gabriel.
And we've just finished clipping that up, and you'll never hear the original intro ever again.
That's right. I thought I'd go around Triple Z and ask a few of the announcers to do a line each from said
cool.
file. Yeah, it took me ages just to write it all down because it's really hard to catch some of the wordage.
Oh, we wrote notes.
Yeah, I got
Now,
no.
correct me if I'm wrong, Gabe, but I thought we specifically asked.
Yeah, I know.
I'm allowing it. Max, coming up in the show, you've got some stuff on bladeless wind turbines.
Yeah, pretty amazing.
Ooh.
Yeah.
I've got some scientists in China who have tracked a rare porpoise using poetry.
Hey. Whoa.
Freshwater porpoise.
Freshwater.
Not
well.
your territory.
Well, Zach will like that.
In the ocean.
I'm going cellular today, which is a region I don't usually delve into because I find it boring, honestly. But today we've got some interesting stuff happening in the cell, so I thought I'd dive in through the microscope.
Good stuff.
Okie dokie, we're delving into the tiny. So scientists from the University of Miami, QS ranking, we're going straight out the gate.
Oh, Miami, 51.
Yeah, I'm going 88.
278. Yeah. Guys got to stop having that pro-America bias. It's down the drain. So these scientists have uncovered over 230 previously unknown giant viruses in the ocean.
Giant
We'll
viruses.
get there. Giant viruses.
Relatively. Gotcha.
Giant.
And they think that these massive DNA viruses might be doing something absurd. But what's more absurd, I'm just going to let you know right now, is the acronym in this story.
Yes.
Achoo.
It's been a while.
I was going to do this anyway, and then I got halfway down, and I was like, oh, Oh, it boils my blood. It gets me so annoyed. But let's take it back a step, okay? What is a virus? Gabe, do you want to have a crack off the top of your head?
What is a virus?
What is a virus? This is Biology 101.
It is Biology 101 because this, I'm pretty sure, was my first lesson in like grade 10 biology.
really?
The first biology class my school let me take. I'm pretty sure we talked about viruses because biology is the study of life and viruses are sitting on the precipice of what we even call life.
Yeah,
Because they
there's
don't
debates.
have the ability to self-replicate, which is what a lot of people put into a definition of life, is something that can self-replicate.
Yeah.
And they can't. Viruses can only plug into and use, kind of take control of the replication abilities of another form of life and then use that to replicate. So
If you
it's
consider them life at
typically
all.
a strand of genetic information, often
Yeah.
RNA.
But sometimes DNA.
Sometimes DNA. And then it's got the ability to lock into another cell, usually override its...
Well, see, it's interesting you said another cell there because a lot of biologists don't even technically think of them as cells.
Sure.
They're just genetic material wrapped in a protein coat or
Love
a
that.
lipid envelope. That's
Yep.
just it. They're just bits of genetic material flying around.
And that protein coat, so something like a coronavirus, like COVID, that was those spike proteins that
Yeah.
the vaccines targeted at.
Yeah, exactly. So Gabe's exactly right. Viruses must infect a host to reproduce. That's what makes them unique. They invade living cells. And when we say reproduce, we mean reproduce their genetic material. We do that within our bodies just by like, what's it called? I can't remember the thing. It's like a zipper and then your DNA recreates itself and
Just DNA replication.
DNA replication. They can't do that at all.
Yeah.
At any point in time. So they invade living cells, humans, animals, plants, or even microbes like bacteria, and they take over the cell's machinery to make more copies of themselves. And then once they've made enough copies, they burst the cell open, leaving it damaged. Usually, not always. And the other thing that viruses can do is they can actually reprogram their hosts. So some viruses don't just use their host to replicate, they will manipulate their host's behavior, which is creepy and weird, but it happens a decent amount. And they sort of, blur the line between living and non-living because on their own, they don't eat, grow, make energy, or reproduce. They only can do those things when they're in a host. So weird. Viruses get a weird science stamp all on their own. Very odd. Odd things, don't like thinking about them. So if that's a virus, what's a giant virus? Essentially, they're just bigger. Just bigger
I'm glad we had
viruses.
to wait all that time to find out.
Yeah. They've got a lot of genetic material in them. So these researchers found 230 new ones. That's a lot of new giant viruses. Apparently, they said that like the usual way they find viruses kind of skips over giant viruses. Didn't really explain why, but there's some sort of computer problem with the fact they've got so much genetic material. So they had 230 of these new ones. But what was even cooler than finding 230 new giant viruses was finding out that they had 530 new functional proteins.
Okay.
So within their DNA, which they had a lot of, again, because they're giant, they
Yep.
had 530 new functional proteins. And it was 9 of these proteins that tipped the researchers off that these giant viruses were doing something really weird. These viruses don't just kill off their hosts, they hijack the biological processes of these organisms, including their ability to photosynthesize. These viruses came with 9 proteins specifically related to photosynthesis, which means when they get into their host, they then put those proteins into the host's body and change what it's doing, which is wild. Really weird. These are proteins that were thought to be unique to cellular life, so it was a bit of a shock to the researchers to just find them hanging out in some giant viruses in the ocean. And it shows that viruses don't just infect them, they reprogram microbes to function differently during infection. And critically, they think that this means they might be shaping how the ocean absorbs carbon, produces oxygen, and even causes harmful algal blooms, the toxic outbreaks like the one in South Australia right now. So all of that could be happening because of some of these viruses, or at least be changing in volume and scale. So now we get to the rage-inducing acronym. Okay, deep breath. So to uncover these viruses and find them out, essentially they looked at these massive global data sets from 9 large-scale global ocean sampling projects, which essentially they get seawater and go through computer programs, then upload it. And then they built a new bioinformatics tool, which they are calling BEREN, B-E-R-E-N. Have a listen out for when those letters come up in this thing. This is the bioinformatic tool for eukaryotic virus recovery from environmental metagenomes. Sorry, metagenomes. So that is the B in bioinformatic. We completely forget tool. The E from eukaryotic.
Yeah.
Screw virus. That's apparently not relevant despite being
I was
the heart
wondering
of
what
this.
happened to the V.
Virus is gone. Then it goes R for recovery. Get rid of from. Don't care about that. E from the environmental. And then we go to metagenomes, and they've taken the N. The N. It's in the middle of the word.
What's wrong with using the M?
Yeah, what was Berem? Why not Berem? Why Beren?
Bevrim would also just be fine.
Like,
Or
why?
Bevan.
Why are we doing this? We don't understand how acronyms work. I don't need, like, who is Beren? Why did they need an acronym named after them so that we had to, like, squeeze these weird letters from the middle of genome, which is in the middle of another word? It's already got a prefix, and you're finding, like, the N in we need to calm down. We need to figure out what we're doing with acronyms. If you need an acronym, just find one. I can promise you, people around the world aren't going to be like, oh, Beren, that's catchy. Let me learn about this, like, viral computer science technology because of that cool acronym. You know, like, people can say eukaryotic in a biology class. They'll be okay.
At least we've got a
promise
sting
you.
for next week, so that's good.
That's good for you. Anyway, then they used a supercomputer and then they looked at the viral genomes. But the most important thing about this study is just that now we have some different things to look at when we're monitoring the environment and trying to figure out where or how these viruses operate, which would help predict algal blooms and climate science and all sorts of huge things. And they think they could even use this Beren thing to monitor pathogens and pollutions in coastal waters, which would be really exciting.
Cool.
So, hate the acronym.
Love the
Cool
word.
research, though.
Yeah.
Sonar stands for what, Izzy?
Sonar
What does
stands.
sonar stand for again? Sonar. From a few minutes ago?
I know what the last word is.
Sonic?
Sound.
Sound.
Yeah.
Okay. I don't know.
And then there's an N word, and then and ranging.
S-O-
And ranging. Near ranging. I don't know. Is that it?
I tuned out.
Sound, navigation, and range.
I got the first half.
Fair enough.
You did.
1 out of 5.
You tune into 4ZZZ, and the show is No Idea, your weekly dose of science with me, Max. We have Issy here.
Good morning.
We got Peta. We
Good
got
morning.
Gabe. What you got for us, Gabe?
Max, about 300 years ago, there was a Chinese emperor who was sailing down the Yangtze River.
The what?
The Yangtze River.
Oh.
It is the third biggest river in the world, the longest in Asia. 6,300 kilometres long.
Yeah.
Jesus.
The width of the Australian mainland, I think, is about 4,000 kilometres.
Good Lord.
So it's huge.
Yeah, that's massive.
It goes from basically from the west to the east coast of China. It's an enormous
Where's
river.
all the water coming from? Anyway,
the
never mind. I'll
sky.
figure that out.
Yeah. It's huge and gets fed. I think it's fed by a couple different mountain ranges. And
There are a lot of mountain ranges.
It's
there,
a
so-
huge part of the cultural history and economic history of China.
Yeah.
And so, but 300 years ago, a Chinese emperor was sailing east down the Yangtze River and it encountered what we now call the Yangtze finless porpoise.
Oh.
Now, translated to
Completely
English,
finless.
translated to English, we'll get to that. He wrote a poem, or at least there's a poem attributed to his name.
Right. Could be
which
someone else on the
says-
ship.
Oh, he was known for being a poet, apparently.
Oh, okay.
So-
Well, I guess if you're an emperor, there's not much else to do.
The porpoises chased moonlight on silver tide as dragons summoned storm clouds loomed in sight.
Aw.
Pretty cool.
That sounds
romantic.
great.
Yeah,
sounds
good
like
you
a
speak
beautiful
English.
holiday.
That was good.
Well, I did say it was translated to English, Max, but it's all right. It's nice to know you tune out every now and then. Now, this porpoise, it's finless, not totally. It's got flippers.
Yeah, otherwise it would just be like a little weird worm.
Yeah. Yes, but it's very small fins. And so it's a weird looking thing.
Yeah.
It looks like, so its porpoises are just very similarly related to dolphins.
They look pretty similar,
and
yeah.
the rest of the cetaceans, which includes right up to the orcas. So
Yep.
it's all one big group. Orcas, dolphins, porpoises are all one big thing that we call different names like whale and dolphin and porpoise because they look different, but they're closely related in evolutionary history. But the porpoises have sort of defined by not having the beak look of a dolphin.
Those shorter snouts sort of thing.
And pretty much no snout on them.
Yeah.
These ones in particular.
Yeah, I've seen
they're
things
a
like
bit
that.
chunkier, the porpoises, typically.
They are, yeah.
They're usually a bit
Rounder.
smaller, or at least they get smaller than the dolphins. And a few other bits and bobs are different as well. They've got sort of triangular fins when they do have them, whereas dolphins have that curved or hooked look. And their teeth are different. They have spade-shaped teeth instead of the cone-shaped
If you
teeth
saw
that
one, you'd be
dolphins have.
like, that looks like a bit of a weird dolphin.
It looks like a weird
It's not
dolphin.
a dolphin. It's a bit of a weird
without
dolphin.
the snout.
Yeah.
So that's what these Yangtze River, Yangtze finless porpoises looked like. And they were previously thought to be a subspecies of a nearby ocean porpoise that seems to now be being pushed out, and they are considered their own species, or at least
social
on their way.
outcasts.
They're classified as their own species, and most people agree they're either their own species or very on their way to being their own species, because there's thousands of years of separated history between them and the ocean-dwelling ones. But there are about 5 living species of freshwater dolphin left in the world. I think it's 5.
Not that common.
Not common. There's 1 freshwater porpoise. This is the only one.
Wow.
Okay.
So it used to share the Yangtze River actually with the 6th living species of freshwater dolphins called the baiji, which is now extinct.
Oh,
So-
did we do that?
Oh, absolutely, humans
Oh,
do that.
great.
And the Yangtze finless porpoise is also having a lot of issues. It's down to about a little over 1,000 individuals left.
Oh, that's not many.
Their population estimates are really hard to do, but there's some genetic information that said that was done in 2017. It's had a bit of a recovery since then with conservation efforts, but in 2017 they said over the last 50 years through genetic information we think it's lost 98%. So it potentially was down to 2% of what its population was just 50 years ago, which wouldn't have been the
Jesus.
top population. The problem then, Max, is okay, so you can use this genetic information to get a look into maybe previous population sizes. You can do sort of you can mimic how much genetic information there should be versus how much you've got. You can look at the genetic information on display in the remaining individuals. You can reconstruct a size estimate. It's just a little bit of the way back in history. But how do you actually look at where these porpoises used to occur? Because the problem is, 300 years ago when that emperor was sailing down the river, and hundreds of years before that, no one was doing rigorous porpoise population counts.
But people were doing poetry.
People were doing poetry, just like the poem that the emperor wrote.
Yes.
There are hundreds of poems that include mentions of the
Nice.
Yangtze finless
Go
porpoise.
spot on, guys. Don't even worry about it.
So, these researchers, Chinese researchers from a couple different institutions, they looked at poems from across 1,400 years, so
Good
1,400 years of worth of poetry. They said there were so many. One of their main problems was how many poems there were to go through and how many different styles of poetry there were that they had to learn. What they were trying to look for is verified locations, rough locations where the poem was written, or at least
Right.
describing, and as well as a verified presence of the porpoise in that poem. Obviously, though,
Verified presence of the porpoise in the poem.
yeah.
Yeah.
So,
Right, science.
which means they
capitalists.
need to have accuracy in what they're looking at in the poem. And poets, of course, are known for their very literal, accurate
Rigorous.
way of writing,
Yeah.
with no flamboyance or metaphor or exaggeration going on at all.
Yeah, no,
That's
people
what
love
poetry-
to say that my lab reports are poetry.
Yes.
I saw this porpoise, weirdly finless, weird-looking dolphin in the river, 2
Which-
o'clock
So
yesterday.
they went through all of these poems. They had to go through one by one to verify. And
Sorry,
that
guys, I've got to go to
included
the lab. Ugh,
read poems.
read my poem.
But also look into the life and writing style of the poet
Oh,
to
God.
look at if the info was accurate. Is
Yeah,
there
yeah.
someone who's
Some random
maybe
guy.
going to be more likely to exaggerate the size of what they saw, so it might not be one of these
I
porpoises?
saw a mighty porpoise.
Yeah,
3 men large. It ate 4 people.
yeah, exactly. And they had to look at all the different names that it's been given in all the different regions as well.
Yeah.
And there's plenty of things that could have
One
been...
of them just called it ugly.
Yeah. The other one called
Weird
the mermaid.
fish.
So there's lots of things to be confused with, including those Yangtze River dolphins,
Right.
as well as also recently extinct Chinese paddlefish, which is a large, definitely confusable with a porpoise-shaped and sized fish.
Right, but it's a fish,
Yeah.
critically.
Yeah.
Doesn't need to breathe, so big difference.
And so they were looking, they were trying to find specific physical characteristics mentioned of the porpoises or behaviors that were definitely the porpoises and not something else.
Right.
That's one of the ways they were able to identify it. They've got
Okay.
very specific ways that they feed. They're known for jumping up out of the water a lot when they feed for fish and push out bow waves and things. So they've got identifiable features that they could look for in their behaviors as well as how they look. And they say they found records of blowing waves, surging waves, bowing to the wind, these sorts of things that they're like, these are the porpoises. There's nothing else that could be that they're describing
Right.
as they're going down the Yangtze River and all of its tributaries that feed into it. And the research that was published in Current Biology revealed that 724 poems were there.
Current biology.
Yes, Current Biology. 724 poems mentioned the porpoises. Half of those contained information about where they were seen. So, over 300 bits of data points over 1,400 years about where these things were. What they found was that they used to be far more widespread than they are now. They're now restricted to a small part of the Yangtze River, which is 65% less than they used to be. So the range has decreased by 65% over the last 1,000 years or so. In particular, those tributaries, so the things that feed in, including the lakes nearby, into the Yangtze River, they've seen a decline of 91% of that range in these finless porpoises, where they're not found there anymore and were there in previous poems throughout history. They say the fact that a relatively small freshwater mammal like the Yangtze finless porpoise appears often in these poems reflects a big cultural connection between people and nature in ancient China, and particularly these porpoises. But also, it documents the fact that humans were the cause behind this range contraction. So it confirms previous evidence and hypothesizing that the biggest declines have actually been quite recent in the 1950s, when a lot of dams were constructed along the Yangtze River,
yeah, that'll do it.
which cut a lot of the habitat up and meant that the porpoises weren't able to move up and down. And so that blocking of movement coincides with a major drop in the population. And they say it also lets us sort of look into things like overhunting and disease and invasive species, other impacts that could have coincided, but they did find that the biggest drop is definitely that relatively recent dam building, and that's where the big population plummet happened. For their next steps, what they'd like to do is go back into these poems. They're not done. They want to go back into
Must
these
be
poems
some pretty good poetry.
and looked not just at where the porpoises were. I keep calling them dolphins. They're porpoises. Go
Are
not
you
just
doing
look
it on
at
porpoise?
yeah, sure. Oy, oy, oy. Not just at what the porpoises were doing and where they were, but also what the river looked like in the past, and try and reconstruct some of their habitat to try and see if that could be something we could restore and then expand their range back into some
That'd
of
be
their old
pretty cool.
habitat.
Yeah, especially if they had like a wet season, the river would be bigger, or a wet couple of 100 years, which has happened. There was a micro ice age. After that, there would have been a lot of water.
I think what
Lots
they'll
of stuff.
find is potentially different levels of flow, cleaner water, that sort of stuff.
They'll definitely find cleaner
And
water.
potentially different prey or more prey available in different areas. I did actually listen to an interesting little presentation at a little research group when I was trying to learn about these porpoises, and they found that they've started doing this thing where they've got some kind of half wild populations in these lakes that come off the Yangtze River that they've closed off, and they've got some in there. And so then they now sort of have, I think 3, this is a few years ago, but they had at least 3 of these ones where they're self-sufficient within those closed lakes. And then they've got oxbows, they call them, the type of lake they are. And then they've got 2 more that were getting supplementary food from local fishermen. So they've got 5 populations in total, 3 are self-sufficient. And they actually had an issue a few years ago where they had a massive winter shock, froze over the surface, and some of them just suffocated.
Oh, wow.
Oh my God. I didn't know that could happen. That's awful.
But they have then seen a bit of a rebound since.
I don't want to go break the ice
population's
to try and help them.
I'm sure they tried, but it can get extremely thick extremely quickly.
Oh my God.
Yeah, just all sorts of environmental stuff can go on. This is the peril you're in when you've only got 1,000 left of a species. That
And also
something
when
small
you
like that can
decide to live in the ocean but still breathe air.
That's right.
Well, they're in the
evolution
freshwater,
They're
but
in
yes,
the freshwater.
that's what I got, Max. Poems showing the past range of the freshwater porpoise.
After reading this paper, traditional wind turbines seem so yesterday. It may take
Oh,
It may take a decade or more, but imagine a world where electricity generated by wind is performed by a series of flexible poles known as BWTs.
oh, I thought you were going to say like those Dyson fans. Yeah, the bladeless
Yeah.
fans, like we just put giant circles into the
ovals.
sky. We're like, woo, energy.
But how
Dyson
would it
would do
affect the ocean, Max? That's my question. And is it related to the BWT motorsports team?
That's right, exactly. And why do they call it BWT when it stands for bladeless wind turbines, where it could have been bladed wind turbines? You might be just talking about the same thing. Anyway, engineers from University...
Another acronym failed.
Yeah, they're from the University of Glasgow. That's where you're from, Issy.
No.
Curious
Incorrect.
ranking.
No,
No.
wrong again, but okay.
Curious ranking.
Oh,
It's
university.
less than
Glasgow,
100.
150.
less than
Oh,
100.
never mind. 50.
99.
It's 42.
78. Issy gets it.
Yeah, I do.
They've used computer
Because
simulations
it's your homeland.
No.
to identify for the first time how future generations of the technology could be built for maximum efficiency. The team's paper, get ready, is titled Performance Analysis and Geometric Optimization of Bladeless Wind Turbines Using Wake Oscillator Model. And it has been
Catchy.
Wow.
Nice.
It has been published in the journal Renewable Energy.
Easy little tattoo right there.
Unlike conventional wind turbines, which convert the kinetic energy of blades propelled by moving air into electricity, BWTs generate power through a process called vortex-induced vibration, or VIV. BWTs...
I'm all right with that. I don't see why you need it, but I'm all right with it.
Yeah. I actually made that up. They didn't actually include that. BWTs take the form
I'm checking.
of
It's not what this show is for. We're not making rogue acronyms. Let's simmer down.
They're structures that they've modelled sway in the wind like steel street poles in bad weather, and as the wind blows against them, the BWTs create vortices. When the frequency of the rocking matches the structure's natural harmonics, the motion is amplified significantly, and the increased motion is then converted into electricity.
Can I tell you what I've got in my head? Like, I think I've got the right thing, which is just a bunch of white poles wiggling. But I'm imagining them
Yes.
wiggling like those car sails,
Yes, very
inflatable
much.
dudes. Just like, woo! Imagine like people go, oh, wind turbines, so ugly. And then you look at a giant field of massively wiggling poles.
Now, I must admit that they're only at the very the infant stages of the design, because the design that they talk about is only 80 centimetres tall.
Oh, well, that's all right then.
And it has
Just go into a little field.
and it has a diameter of 65 centimetres. So it's fairly square.
Wait, sorry,
right?
what?
I know, 65
Oh,
centimetres
I've seen this.
diameter, 80 centimetres high. But they reckon it will deliver a maximum of 400 watts of power, significantly better than real-world prototypes built to date, which can only deliver a maximum of 100 watts. So a
Wow.
4 times increase, yeah. Their model also demonstrated the limits of other BWT designs. In their paper, they demonstrate how different designs of BWTs could, in theory, generate up to 600 watts, but at the cost of structural integrity in real-world conditions, and they would quickly fail. The teams say that their methodology could prove the foundation for scaling up BWTs to utility-grade systems generating 1 kilowatt and beyond, making them much more practical for use by renewable energy providers. And one of the paper's authors, Dr. Rick Malik, remarks, we have identified the ideal midpoint between the design variables to maximise the ability of BWTs to generate power while maintaining their structural strength.
I'd put one in my backyard and then put like a little funny costume on it. Googly eyes.
I have seen this design before in a very viral Instagram video that's made reference to someone's bedroom drawer. So the design might lead some...
It's flat.
Along the same line, Izzy, I was curious, Max, is there a balding billionaire who's behind this development by some stage?
I was going to say, there's no woman on the
signature
team.
phallic shape to this.
Unfortunately, I don't think we'll see these guys wiggling around anytime soon.
And we got Mike texted in. Mike says, loving the acronym chat, smiley face.
Cute.
We always do.
Well done, Peter.
Biological representation in emojis is a joke. I'm sick of it. You keep looking for stuff. There's like 4 versions of a chicken and one eagle, and then there's no other birds.
Okay, but we do need to acknowledge our
There's
own
no
privilege
moths.
in this situation, is that Japanese people love Australian animals, and so there is a koala and a kangaroo on there. Like, we're slightly
super cute.
overrepresented.
And 2 types of
if you
mushroom.
compare that to New Zealand, there's no kiwi.
There's only like 2 trees. One of them's a sapling.
Hey, there's a palm tree.
Yeah.
You tune into 4ZZZ, and the show is No Idea with me, Max, Izzy, Gabe, and our friendly neighbourhood marine scientist, Peter. What do you got for us?
All right, what do you guys think of when you think of sea cucumbers?
Sea cucumbers. Big, floppy loaves of bread on the sandy
Yeah.
floor.
Look a bit like a bladeless wind turbine.
That squirt.
They do.
We were trying to be subtle, Max. Yes.
They look a little bit like a bladeless wind turbine, or they have a similar
Form factor.
idea.
and various shapes and sizes.
There's loads of them.
Like a lot of the bladeless wind turbines you could buy online.
Yeah.
You can get long, skinny sea cucumbers. You can get short, skinny sea cucumbers. You can get big, fat, bumpy sea cucumbers.
Yeah.
All varieties.
Look, many varieties. One of my favourite ones, just for reference, is one called the pineapple sea cucumber, because it's got these like little pineapple-y sort of like bumps on it, and it's one of the few ones that you can actually pick up, and it doesn't have like a depressurization issue, and so you could pick it up and show it to tourists.
Right.
And they would be fine with that.
Vacuums of the sea, they're called by some people, right?
They are called that. When I think of sea cucumbers, I think of one sea cucumber called Herman, because there was this one guy who was doing his PhD on them, and his PhD was just following them around to see how much they pooped. And he predictably went crazy because he'd been doing that for hours on end, weeks on end, months on end, just following sea cucumbers around in the ocean. And so he named his Herman, did a fake interview, and then posted it to YouTube. It's just
love
it
science.
was a really nice way of warning us about the perils of science, namely losing your mind. But sea cucumbers are best known as soft, squishy, bladeless wind turbine shaped creatures that clean the ocean floor by recycling nutrients. Essentially, their butt in motion. Just how good is their butt? Their butt makes the ocean go round. But researchers at the University of Mississippi, QS ranking.
Okay. I know they're in America, so we can't use the bias, can we now?
Yeah, get rid of that bias.
330.
450.
80.
851 to 900. And that's good for them because last year they were in the thousands.
Hey!
Yay! Go University of Mississippi. But they have found out that some sea cucumbers may also hold a powerful secret weapon against cancer. So sea cucumbers could be useful for more than just their butt. Yay! From what I can tell, these researchers were just generally looking at proteins and compounds produced by sea cucumbers. Like, they didn't say like, oh, we saw the sea cucumbers could do this and we wanted to know how they did it. They just sort of leapt in with what exactly this one compound of the sea cucumber can do. So I think they were just playing around with sea cucumbers because one of the researchers was like, oh yeah, things in the ocean, there's loads of compounds that we just have no idea about. They're also looking at corals and all sorts of things for lots of compounds, mainly for medicine, which is a thing we've been doing forever. Like, we haven't exhausted plants by any means, but we've looked at a lot of plants, and so now they're like, 70% of the world is ocean. I bet there's a bunch of really cool compounds in there. And that's sort of where we're at. But primarily, they found that one compound from this one sea cucumber could inhibit what is known as SOLF2. So what is SOLF2? Let's step back a bit here. Every cell in the human body is covered in structures called glycans, which are complex sugars that sort of look apparently like little hairs. Which I didn't know this, but apparently lots of our cells are covered in little hairy things that are made out of sugars that help with communication, immune response, and recognizing threats. So they're sort of like a communication system between cells. Cancer cells, however, manipulate enzymes like SOLF2, so it's just an enzyme, to change this glycan forest that's our cells helping them evade detection and grow unchecked. So cancer does this thing to this one enzyme called SOLF2 that helps them grow. However, this compound from the sea cucumber they have found they think inhibit SOLF2, which essentially they think what will happen is that it stops the glycan reprogramming and effectively slows or blocks cancer's ability to spread, which would be huge, right? Like, this is up in the realms of, quote, cure for cancer. Huge, huge, huge deal. So how did they figure this out? Essentially, they found this compound, and then they were like, we think this might have this inhibiting factor. So they did a computer simulation, which is, I think they have the structure of the compound and the structure of the enzyme, because they're just molecules at the end of the day, and saw how they interacted. And then they had a lab-based experiment to test the effects of the actual sugar compound called fucosylated chondroitin sulfate, which is the one that they took from the sea cucumber. It's just the sea cucumber just looks like a sea cucumber. Like, you wouldn't be able to go down, like, poke your head underwater and be like, that's the one, that's the fancy sea cucumber. It's a sea cucumber. And their approach included, like, they sort of did this molecular modeling to see how it interacts. Then they did it in a lab, and they kind of went like, okay, both of these things are consistent across the computer and in real life. And they found that, yes, fucosylated chondroitin sulfate, really, that's the
Catchy.
second one's really getting me there. Chondroitin. Fucosylated chondroitin sulfate can inhibit SOLF2. Ding, tick, done. They think they're very confident that this could prevent the spread of cancer. And they're excited because, unlike other drugs that target similar enzymes like SOLF2, so we already have drugs out there for, like, cancer drugs that are already doing this sort of mechanism, but those drugs interfere with blood clotting, which is a common side effect with many cancer medications, which is very dangerous and causes a lot of pain for cancer patients. And so they think that this doesn't do that. So they're hoping that it would be a really good drug, that it would have very few side effects. It's derived from marine life, which means that it avoids some of the risks involved in sourcing similar drugs from animals like pigs, which apparently they have, like, potential for viral transmission and all these complicated things. So they think having it from a sea cucumber might sort of circumvent all of those issues. But then we come to the sort of big issue. So while this one is not carbohydrate based, so it would be sort of easy to synthesize, they haven't synthesized it yet. It needs to be synthesized because otherwise you have to go around plucking sea cucumbers out of the sea and getting this one compound out of them, which obviously is not sustainable, like, in any way. There's not enough sea cucumbers in the sea to do it. So they think that if they can synthesize this molecule, which they believe is possible and not too difficult, they should be able to create large enough quantities for testing, moving forward into animal models and eventually human trials. Now, obviously, this is still a long way off being anything resembling medicine, but it is a really cool thing that they've found in a sea cucumber. It's yet another example of the ocean providing really cool medicine. And yeah, it's something to keep our eyes on in the background.
Yeah.
Gabe has a lot of penis facts in his brain, just generally.
That's going to be another little
Another sting for the show.
thing for the show. There we go.
All right. Now, the good thing is we may not have Max, we may not have Gabe, but we do have
Penis facts.
Triple Z.
We want to appeal to your senses.
You tuned to 4ZZZ. The show is No Idea with me, Max. We got Maximillian in the room. We got Issy, and we got Gabe.
Okay, it's time for the best part of the show. Loosely defined as science, yeah, you already know. Everybody listens to 4ZZZ just to hear us talking about what Butters just did. Subscriptions just keep rolling like the tires on a car. But something tells me that our science curves won't go far. But unlike an engine, I won't keep you in suspension. We're all here to hear him talk, so let's give him attention. You're not ready for when he starts rapping. Gonna hand the mic to Max, and I'm not talking Van Stappen.
Everyone ready?
Yes, sir.
Locked in.
With Australian drivers racing in F1, F1 Academy, Le Mans, IndyCar over the weekend, the question on everyone's lips, would I be playing the Australian national anthem during today's MotoRap? So you'll just have to keep listening to find out. F1 happened on the weekend. It was in Canada. It was a traditional race weekend format comprising of free practice 1, free practice 2, free practice 3, qualifying, and the Sunday's feature race. Qualifying saw the luckiest/unluckiest driver, George Russell, finish top of the timesheets. Position 2 went to Max Verstappen in his Red Bull, and starting from position 3, well, you almost want to play the national anthem now, don't you? Aussie Oscar Piastri Then things went a bit pear-shaped for Oscar from the get-go because a young Italian schoolboy driving a Mercedes by the name of Kimi Antonelli forced his way past Aussie Oscar by about second corner.
Yeah, and it's good to see like the improvement in Antonelli, like even just from Miami, which wasn't that long ago. Suddenly now he is willing to get his elbows out a bit and muscle his way through. Good stuff.
And his exams are nearly over, so...
But fully, I was so perplexed by how Kimi got so high up. So I rewatched qualifying just to see how he jumped from
fourth to third,
from 8th to 4th, and then 4th, so on.
True.
So I wanted to see what happened because as a rookie, that's incredibly impressive. It's definitely worth watching, keeping an eye on those qualifying highlights to see Kimi slowly work the way up.
Yeah, exactly. And then, so that was basically it, wasn't it, really, from the get-go? Once that order, the top 5 just all finished the same, didn't they?
Yep.
Pretty well?
Yeah, settled into a groove.
Yeah. And it was good to see both Mercedes drivers on the podium. The Mercedes team is...
First time this year, right?
Yeah. And that puts them into second in the constructors below McLaren. But there is a 175-point gap, so I think McLaren's already wrapped that up for the year. By finishing 4th, Oscar Piastri maintains his lead in the Drivers' Championship by 22 points ahead of teammate Lando Norris.
Now, that gap sounds a bit bigger than it was last week.
It should have been just 8 after the race, but no. So talk us through what happened to Lando.
Well... He pulls this very interesting move into that final sort of hairpin before the back straight. It sort of catches Oscar a bit napping, which is a great move. I mean, you can do so many great things at that hairpin. Gets past Oscar, and they're sort of neck and neck on that back straight in the DRS zone. Then they go through, they both avoid the Wall of Champions, thank God, and they get through. But by turn 1, suddenly Lando's missing his front wing. Yeah. He's gone into the back of Oscar.
He wanted to drive underneath Oscar Piastri by the looks of it. I don't think that's possible.
No, it's like there was this... He thought he saw a gap on the left, but it just...
It's called a
It
wall.
wasn't... As Corinne Shandok put it, it wasn't exactly McLaren-sized, this gap, so...
Gabe, what did you think? Gabriel?
Yeah. No, I'm here. It was... I don't know. It felt like Canada's supposed to throw up a bit of a race. It's one of those courses that a bit like the Melbourne track, always just make something happen, even though on paper it maybe doesn't have a huge amount going for it. But not much happened in the race.
Other than that, really.
until that incident with Norris, which was Norris's fault, and he acknowledged straight away.
That was good to see. That was really good to see.
Yeah.
And just very lucky. I think we're very lucky that the Aussie Piastri didn't get a puncture in the process because the front wing of his teammate broke off on his back tyre by the looks of things, which usually causes a puncture.
I mean, they brought him in, I think, just as a precaution anyway. They had the free stop, so.
Yeah.
But it could have gone a lot worse. But other than that, I don't know. It felt like a bit of an uneventful race. I'm very keen, Max, for next season when the regs change. It does feel a bit like... I've been noticing a lot this season. I look at the timing board on the left of screen during the race, and about half of the drivers are right above or below their teammate. And it's like, when you've got this natural filtering of just it's wherever the cars are performance-wise. Like it's just the 2 Alpines next to each other and the 2 McLarens next to each other, and the 2 Kick Saubers next to each other, all the way down the order. That seems to be happening with a couple of exceptions. I feel like pulling away a lot of the racing when they're just filtering out like this into their team order.
Is that enough for the F1 so far?
I think so.
Yeah.
Okay, F1 Academy. Izzy, talk us through it.
3 races in Canada. We saw the women racing in Montreal this weekend alongside F1, with the Gatorade-sponsored German driver Matilda Patz as the wildcard entry. Right. But of course, this weekend was not without controversy. In qualifying, it saw Red Bull driver Raffaella Ferraria set a 1 minute and 37 seconds .156 time, which put her in P9. But sadly, the Brazilian lost the time after after being judged to have exceeded track limits in turn 1. Her race time was later reinstated after the race after Stewart's evaluation. In race 1, we saw Dorian Pin, the French Mercedes driver, come through with the win, but Kick-Sauber Emma Felberman was disqualified after her car was seen to be below minimum weight at 602.6 kilograms, below the minimum of 603 kilograms. Additionally, Alicia Pawlowski was awarded a 10-second penalty for causing a collision with Chloe Chambers in turn 1. And so we had Nina Gademan as promoted to her first F1 podium as a result, coming in 3rd. In the second race, we also saw another penalisation as Nicole Harvard was handed a grid penalty for race 3. This was the catch-up race from Miami after it got rained out, for causing a collision with Ava, who is our local Aussie driver, who came in place at she came in P8 in race 1, and Joanne Caton came in P9 in race 3. So a weekend of a lot of collisions, a lot of very exciting moments, but of course with a little bit of controversy. The girls will be racing, I think, not for a long time. I think, let me double check, they'll be in the Netherlands in August, at the end of August, for round 5.
And in the American Chloe Chambers, she won race 3 and she came back from race 2 because she got disqualified from race 2.
She did get disqualified from race 2.
Did.
Also, race 2 saw Emma Verbeenen, who had previously been disqualified in race 1, come through winning as well. So this is definitely one of the more exciting races that the girls have done. So if it's worth watching it's worth watching the highlights, please do, because it is quite interesting to see the strategy coming through. And also 3 races. Are you kidding? You're definitely fed for content.
NASCAR also happened on the weekend, and they celebrated an international race of sorts. In a NASCAR first, the teams travelled over the southern border to Mexico.
Ooh.
With bad weather on its way, qualifying saw all cars on track at the same time, so the starting grid could be sorted. NASCAR prefers dry weather running. This played perfectly into the hands of former supercar champion Shane Van Gisbergen, who set the fastest time. Would this translate into a win? Of course it did. Much like his debut NASCAR Cup race in Chicago 2 years ago, Shane was able to tame the tricky Mexican road circuit. The F1 calendar also includes this particular circuit. So in a post-race interview, SVG said he had been in contact with Max Verstappen before the race to ask for any pro tips. Max told him what lines he should use if it were to rain, and it did rain in the first few laps. The 100-lap race, the track soon dried out after the first few laps, and Shane took command of the race, finishing more than 15 seconds ahead of his nearest rival, Christopher Bell. So I would call that job done. And then Le Mans 24-hour also happened on the weekend.
Big weekend.
One of the most prestigious endurance events. It was a Porsche-Ferrari podium. Australia's Matt Campbell was one of 3 drivers in the number 6 Porsche that came home in second. So no anthem there.
What is interesting is one of the Ferraris has been disqualified, the 4th place finisher.
Oh, yes. Yeah.
Number 50.
Yeah.
So, for a flexi-wing infringement, would you believe?
And
of all things.
Also, IndyCar also happened on the weekend. It was in Madison, Illinois. Aussie Will Power started from pole.
Oh, wow.
Was it this be the redemption and a chance to play the Australian man? No. Sadly, Will crashed out during turn 4 on lap 4. The race winner was Kyle Kirkwood. Any more to add?
Just that MotoGP's on 10 p.m. Sunday, and next F1 is next weekend.
Good stuff. Also, Renault CEO Luca De Maio has resigned, yeah?
Yeah.
That's probably the other big news that broke this week, but we can talk a bit more about that next week.
What do you got for us, Maximillian?
Well, a couple of weeks back now, Apple had their big announcements of all the new features coming across their product lines, and looking past the Windows Vista-esque liquid glass UI that they're going for. I scrolled through the press release a bit, and I looked at the mention of the game porting toolkit number 3, and really interesting to see that Apple putting a little bit more investment into this gaming stuff as well, because they've also acquired their first game developer, Rack7, the Vancouver, British Columbia-based developers of Sneaky Sasquatch. And it's kind of common for a lot of software companies to have like a stable of first-party developers. I mean, Microsoft has countless. So it's interesting that this is now Apple's first. in a very long history of the company, this is now their first game developer, you know. But you think about like how popular like games are on iOS and stuff, and they're these really like sort of platform selling sort of titles. But Apple have always had this really weird relationship with games, and a lot of it does come from Steve Jobs' attitudes towards the software, because he feels like, you know, it's maybe not that much of an intellectual pursuit, but again, begrudgingly, they are system sellers. So the last time they were maybe looking at acquiring a gaming company was, again, as a lot of these segments I've done, you guessed it, takes place in the late 90s. So Jobs had been brought back into the fold for a couple of years after Apple had acquired Next, and he was spending a lot of time at Pixar as well at this time, and he enacted a few really core strategic changes at Apple, with a real keen focus on revitalizing the Mac platform, which was, of course, what had got him ousted from Apple in the first place. So, late 90s, one of the big system sellers for personal computers is this rise of the graphical accelerator or graphics processing unit, enabling these, real-time 3D accelerated graphics on your like home computer. You didn't need to go get a Nintendo 64 or whatever. You could just have that, or go to an arcade or anything. No, finally, this was on your desktop. And sort of parallel to all this, one of Jobs' direct reports at the time, Peter Tamte, decided it was time for a bit of a change. So he joined darling Mac video game developer Bungie, and he set up this meeting between Steve Jobs, Jason Jones, who's a co-founder of Bungie, and Joe Staten, who was the cinematics director at Bungie at the time, to show off their next game called Blam. And it showed off this island with an alien structure. They had this really cool technology where they had, like, the island terrain would be rendered almost completely separately to the structure. So they almost had two separate game engines with separate physics simulations and stuff. And they had vehicles with really cool handling. That was sort of like their core thing, like having this Jeep that could go around and realistically interact with the terrain. And they had a dynamic weather overlay system, and they also had these drop-dead gorgeous lens flares. So this is what Jobs locks onto, and it says, like, look, we can do like 6 of those in one scene at Pixar. Why is this special? So, well, could you do that in real time? Jobs pauses for a minute, says, okay, you're in the presentation. Promptly leaves. He'd seen enough. He was convinced that this was going to be the next big thing in gaming, and it was going to be on the Mac. So on the 21st of July, 1999, at the Macworld conference, Steve Jobs announced Bungie's next title, Halo, to the world. Now that sounds a bit weird, doesn't it? Because Halo ended up coming out on the Xbox.
It did. That was their big leading game, wasn't it?
Yes.
Yeah, so Microsoft were looking for titles for their upcoming games console, the tentatively called the Direct Xbox. Eventually they call it the Xbox, yeah. And well, how did this happen? How did this get stolen away from Jobs? Peter Tamte. So Bungie were in dire financial straits, and it fell to Tamte to basically build a paddle, get them out of this. Microsoft were in, as I said, were desperate need of games. They needed to fill out this library. They didn't really feel like they had any real winners. And Microsoft also were pretty keen, because any opportunity to stick it to Steve Jobs, good stuff. And unfortunately, Jobs did catch wind of this, but it was too late. The ink was wet at that time, and in June 2000, Microsoft had fully completed the acquisition of Bungie, and Jobs was ropeable by all accounts.
He doesn't like to lose, does he?
No. Yeah. So he calls up Steve Ballmer, who's the then CEO of Microsoft, venting his frustrations. Amazingly, he did actually get basically every concession he wanted, including the fact that Halo would still come to the Mac. And Tamte and Alex Soropian had to show their faces at the next Macworld. And I believe Alex Soropian put it, as co-founder of Bungie, another co-founder of Bungie, he put it, he was just thankful that there were no snipers in the audience. Of course, it does eventually come out for the Mac, but what's really interesting about Halo, just as a title, Jobs picked it very well. The idea that this was like a really innovative team, innovative technology behind it as well. And what ended up happening was, when it went to the Xbox, was effectively they rewrote the entire stack to take full advantage of the hardware and the new DirectX 8 features that were sort of being championed as part of the Xbox. They had NVIDIA's NV2A chip, which was basically from the future at that point. It sort of the first sort of emergence of the program, what we would call a programmable pipeline on the graphics processing unit, which is then eventually what has led to like the current AI boom and things like that. this sort of through line there. But no, they had so many innovations, including being able to have the bump mapping, which one of the first games to ship with that, where you use a 2D image to get effectively some fake depth on surfaces where you wouldn't be able to actually render that traditionally in real time. And also then that interacts with really nicely with the per pixel lighting, which you can see in the flashlight in the game. They ended up unifying the two engines, so they ended up having all the structures were represented the same, terrain represented the same, simplified it, good stuff. AI was a big one. In fact, they even got in trouble with Microsoft for giving a presentation at GDC talking about how they did all that. And the other big one was also the controller, because most people... The general opinion was that you could not do a game from a first-person perspective on a console. It just does not work on a thumbstick. You need, like, the precision of a mouse. And a lot of effort was spent at Bungie to... They spent so much time just tweaking the controller so it was more in line with what the player's intent was rather than what the player was actually inputting. So things like magnetism on targets, things like that, to really make the experience smooth. And by all means, it was a massive success. And I think the internal opinion at Microsoft was that there would not be an Xbox 360 had they not managed to snipe Halo from under Steve Jobs' nose. So really good stuff.
Gabe, you a big fan of Halo or not?
I played it.
Yeah.
That's about it.
Is he?
Yeah, I've played it a few times.
Yeah. It's good fun. Yeah.
It is good fun.
Yeah.
No, how interesting.
0, 1, 2.
And this is what they recovered using AI in the data set.
Thank God someone's working on this. I don't know what I'd do without it.
You tuned into 4ZZZ, and the show is No Idea with me, Max. We got Gabe, we got Peta, we got Issy. But before we get into Issy's story, we had a subscriber. You might have heard the baby half seal. Anna from Holland Park, thank you very much. And if you want to subscribe like Anna did, go to our website at 4zzz.org.au/support. You can pay as little as $40 for a concession, a full is $80, or passionate $140. Or you can ring Stephen downstairs on 07 3252 1555 and he'll walk you through it. Okay.
All right.
Admin is done.
Nice.
Easy.
Time to take over. Wake up, babes. New jumping spider in Aotearoa identified.
My mom's going to be so disappointed. She's always proud of how Aotearoa has no spiders.
Well,
she's like, this country.
Is she based in the North Island or the South Island?
We're from the North.
Yeah,
from the North? Well, you guys are pretty much safe because this one is from the South Island.
Sucks to suck, South Island.
Exactly. This is from Lincoln University, QS ranking.
Oh.
180.
I've been so
112
off today. My instinct tells me 150. I'm going to say 400.
Oh, Gabe, you're close. 371.
Going against your
always
instinct.
Yes.
Always doubt yourself.
Always doubt yourself, Gabe. Well, these researchers identified a major gap in research for kiwi jumping spiders, despite the fact that jumping spiders as a species is one of the most heavily researched in the globe. They collected...
Because they're cute.
Yes.
People think they're cute.
And also, I think they are quite prominent as well. Like, oh, I know a spider. Oh my God, they start jumping. What the hell is going on?
Yeah, and people are like, I want to know more about that one.
I want to know about the freaks.
It stands out.
Why are they doing that?
Yeah.
They have very interesting intelligence too, because
Yes.
they're predatory spiders, and they're some of the few spiders that will actually actively go and hunt prey, not just wait for prey
Oh.
or catch prey. They'll go hunt it. That's
There you go,
where the
Mum.
jumping's
Another
from.
reason to stay out of the South
And
Island.
so there was some there's some, I don't remember what the species was, but there was a species of jumping spider that has some level of object permanence and 3D mapping,
Object
because
permanence.
it's able to see prey and then hide itself upon approach. So it's able to calculate where the prey is. It knows the prey has a line of sight or potential line of sight to it, so it can hide
To
itself
ambush it.
That's
as
crazy.
it approaches.
Yeah.
Crazy for a spider.
So they collected 170 jumping spiders from Aotearoa's alpine region in the South Island. So you should be all
All right,
good.
cool.
Which covers 11% of the total island area. To paint a picture of this environment, it is exposed to extremes of high ultraviolet light in summer, snow and ice cover for several months in the winter, and temperature ranges from negative 15 degrees to 27 degrees. So quite a versatile environment. And of course, with climate change, it is not getting any better. Sometimes it is getting even hotter or even colder. So as pointed out in the study, this is a perfect time to kind of start collecting this information because we may actually lose these species as the globe starts heating up. So between 2022 and 2023, researchers visited 19 South Island alpine zones and 4 lower altitude rocky sites. They were
what an awful research.
Yeah. Did they take your skis with them?
Well, it is I'm going to try and find. Oh God, it was so funny. In this article they outlined how difficult it was to find these jumping spiders because not only are they camouflaged, but also these areas are quite hard to reach on field. So difficult appears about 6 different times in this study.
Like, guys, it was hard. I promise it was hard.
It was really hard.
Really hard.
Yes.
I had a hard time.
Including in the methodology, they said the spiders were either captured from the ground surface with difficulty due to their swiftness.
I'm just imagining researchers on a mountain surrounded by like beautiful sights, but they're just on the ground, like you know when cats are trying to get a laser beam, like that's them being like, oh, you got it, Greg.
Or they use silken tent-like shelters built under rock, so you can now imagine field work. People out there waiting for spiders to enter these little tents. So.
We've really fallen as a species.
So after capturing, though, they examined them under a dissecting microscope, and DNA was extracted from leg muscle tissue to kind of help code them into the rest of their species. From this result, researchers found 13 undescribed taxa, with 10 of those found exclusively in the alpine areas, 1 in rocky habitats above the tree line, and 1 only seen at sea level. Super exciting.
I like the sea level one.
The sea level, yeah, I figured. So what does that mean for the larger species? Well, these are some of the largest jumping spiders found in New Zealand. So if they are having difficulty capturing them now, I can't imagine any smaller taxa as well.
Small ones are just going to be like, we took a photo of it. That's
we watched them. Yes, fully. So there have been, descripted in this was like they could take photos on like a Samsung Galaxy phone to capture some of them because they couldn't physically capture them. They could only have photos of them. So what does this mean?
We're not sponsored by Samsung.
We aren't. I'm sorry. Just saying. But they have been
oddly particular about your phone.
I know. I was reading.
Well, they have to put it in the methodology, man.
It's part of the methodology.
That's science.
But this research has contributed more to the Aurea genus, with Aurea being derived from Greek mythology to reflect the alpine distribution of this species, and is quite masculine in gender as well. They have outlined a few times in here. I think they struggled to find female spiders in here.
Oh.
And a few of them even escaped, as outlined in the discussion. Weirdly,
females are just built different.
They are built different.
You can't catch me. Don't even try.
Interestingly, this study includes new taxonomy, so I wouldn't recommend reading this article. I don't think anyone with arachnophobia will be reading it anyway, but there are full front, body, back, everything shots about these new animals. Shots. Yes. And it further informs the New Zealand jumping spider research family as well. I think this is really interesting to fully go out and just see what you can find. And as a result, we have now 13 new unidentified species or
I'd
taxa.
love to read their proposal for that, or they were
fully.
So my plan is to go out into the Kiwi wilderness, hang out there, and hope I find something.
Yes.
Money, please.
Yes.
Right.
It's
very
a genius
rigorous
idea.
Yes.
I do like this. This is from the discussion. Several of the species described here are based upon a small number of specimens. This is due to difficulty in collecting enough of these animals, especially in the sites where it took many hours to access on foot. So shout out to...
We did a hike. We got to the spot. We didn't have long. We had to get back.
Only 3 individuals were seen during the day of searching. 1 escaped, and the female remains unknown.
That's terrific.
So, shout out to Lincoln University's fieldwork. Thank you for your honour for presenting us.
Sacrifice.
Yes, with brand new jumping spiders in the South Island of New Zealand.
Let's get into some space news. No idea. Space news. On this day, back in 1977, the space shuttle test model called Enterprise carried a crew aloft for the first time.
Ooh.
Did you know about this?
No.
I didn't know there was one called Enterprise. I feel like I should have known this.
Sadly, it was
being a Star Trek fan.
to do this feat, it was attached to a modified Boeing 747. So I was just testing it. And then in 1983, another space shuttle called Challenger launches the first American woman into space, astronaut Sally Ride.
Oh, nice.
Sadly, she passed away in 2012, aged 61. But there is a new documentary about Sally Ride, which has just been released, so you can catch that on the streaming services. Now, Big Bang. There might be a bit of a chicken egg thing going on. The Big Bang is often described as the explosive birth of the universe, a singular moment when space, time, and matter suddenly come to be. But what if this was not the case? What if our universe emerged from all things, a black hole? New calculations suggest the Big Bang was not the start of everything, but rather the outcome of a gravitational crunch or collapse that formed a very massive black hole, followed by a
supermassive black hole,
followed by a bounce within it. Crucially, the bounce correlates within the framework of general relativity, which applies on large scales such as stars and galaxies, combined with basic principles of quantum mechanics. With the
basic principles of quantum mechanics. So everyone should know those ones.
And this is done by mathematicians, by the way. And they demonstrated that their new model, unlike conventional Big Bang theory, does not require exotic fields, extra dimensions, or speculative physics. What emerges on the other side of the bounce is a universe remarkably similar to our own. Even more surprisingly, the rebound naturally produces the two separate phases of accelerated expansion, that's called inflation, and dark energy, driven not by hypothetical fields, but by the physics of the bounce itself. And if you want to read more, you can check it out, the article. It's on the Conversations website, and it's titled, What If the Big Bang Wasn't the Beginning? Any more to add,
It was the big
Gabe?
bounce.
Yeah.
No, you crushed it, Max. Yeah, it's fascinating. It's a really good read. I highly recommend looking into it. This idea that the black holes are potentially a source of the universe.
Does that mean that the black holes we see in our universe each have a universe inside behind them?
They could, potentially, if there's a bounce back. Yeah.
What?
Also,
I'll stick to the ocean.
In some unseen footage. Did you see those dolphins that greeted them when they landed?
Mm-hmm.
Well, apparently some were seen leaving Earth and saying so long and thanks for all the fish.
Oh my god. I was wondering where you were going.
Oh my god.
You're tuning to 4ZZZ, and the show is no idea, but not for much longer. Sign us out, Gabe.
That is all we have time for. We'll be back on your airwaves next week, 10 a.m. Brisbane time on Brisbane's community radio station 4ZZZ, 102.1 FM, or on the 4ZZZ.org.au website, or on the Community Radio Plus app, or wherever you're listening live. Wherever it may be. We're there.
Yeah.
Between now and then, publish some poetry about all the species around you, succumb to the large viruses that control our oceans, spare a moment to appreciate the tenacity of Kiwi field biologists, and contemplate the beginnings of the universe. You can catch all those stories on our podcast, which is on wherever you get your podcasts from.
It's the highest rated podcast.
5 stars.
5 stars
Five
only.
Yeah.
Solid 5 stars. Give us a listen. I think once you listen to it, I think it's a minute of the podcast. That's all you'll need.
I think Spotify's now like 3 episodes or something.
Whatever it is,
Yeah.
you'll be hooked anyway. So once you've gone through your listening, make sure you keep us at that highest rating. Drop us a 5 stars.
Search up No Idea 4ZZZ. That's No with a K. And the full show recording with all the tracks and everything we talk about throughout is on the 4ZZZ.org.au website as well if you want to listen to that instead. Please have a look at subscribing to 4ZZZ. It is what keeps us on air and on podcasts and everything else. Look up subscribe to 4ZZZ or support 4ZZZ, and those options will come up, as well as the monthly sub prize you can go into the running to win. But that is all we have time for.
And we'll speak to you soon.
I'm a goddamn marvel of modern science.